Welcome to the channel. Today, we're diving into the fascinating world of semiconductors, the tiny materials powering billions of devices, from smartphones to solar panels. By the end of this video, you'll not only understand P-type and N-type semiconductor materials, but also how they're used in applications that shape the modern world. So, what exactly are semiconductors? Picture a middle ground between electrical conductors like metals and insulators like rubber. Semiconductors are materials like silicon and germanium having conductivity between conductor and insulator to enable controlled electricity flow. Their magic, however, is unlocked through a process called doping. Now, what is doping? Well, doping is the intentional process of adding tiny amounts of specific elements to a pure semiconductor material. By changing its atomic structure, we can make the material conduct electricity differently. And that leads us to the two types, N-type and P-type semiconductors. Let's break them down. First up, N-type semiconductors. If we take pure silicon and add an element such as phosphorus or arsenic, elements with 5 valence electrons, something amazing happens. These extra electrons are freed up to move around. And since electrons carry a negative charge, we call this an N-type semiconductor. The N stands for negative, meaning the material's majority charge carriers are these free electrons. Key points. It's doped with group 5 elements. Extra free electrons are created. Negative charge carriers dominate. Now let's explore P-type semiconductors. In this case, we add an element like boron or gallium, elements with only 3 valence electrons. These create gaps, or holes, in the atomic structure where electrons are missing. These holes act like positive charge carriers because when electrons move to fill them, it feels as though positivity is flowing through the material. The P stands for positive, and the majority charge carriers here are these holes. Key points. It's doped with group 3 elements. Holes are created instead of free electrons. Positive charge carriers dominate. Let's quickly compare the two. N-type semiconductors are rich in electrons, doped with group 5 elements, and carry negative charges. On the other hand, P-type semiconductors are full of holes, doped with group 3 elements, and carry positive charges. But why do these materials matter? Because together, they form the building blocks of almost all modern electronics. Here are just a few examples. p-n junctions, pairing P-type and N-type layers, creates diodes, allowing electricity to flow in only one direction, perfect for powering circuits. Transistors, combining N-type and P-type materials, enables switches and amplifiers, the foundation of every computer chip. Solar cells, p-n junctions, are used to directly convert sunlight into electricity, making renewable energy possible. LEDs. When electricity flows across a p-n junction, light is emitted, lighting up screens, bulbs, and so much more. From microscopic doping to game-changing technologies, P-type and N-type semiconductors are at the heart of today's electronic revolution. Thanks for watching. Don't forget to like, share, and subscribe for more tech topics explained simply.